Computer. Good morning and welcome to the Federated Wireless Showcase at the Forum Europe Spectrum Management Conference. Thank you so much for joining us. I'm Jennifer McCarthy, Vice President of Legal Advocacy for Federated Wireless. And joining me today is Kurt Schabach, our Chief Technology Officer. We appreciate your time and look forward to walking you through our presentation on enabling private wireless networks through shared spectrum. Kurt, will you do us the honors of starting our presentation, please?
Absolutely, Jennifer, and nice to be with you all. Again, I'm Kurt Schabach. I'm the CTO for Federated.
And thank you to the Global Forum team for having us today and this week at all the sessions. So Kurt, take it away.
Great. Quick introduction on Federated. We are a company based here in Arlington, Virginia, just outside Washington, D.C. And we were founded in 2012 by scientists and academics that worked at Virginia Tech and within the U.S. Department of Defense and advanced R&D capabilities within the U.S. government like DARPA. The premise of the company when we were founded was all about spectrum sharing. In the 2008 timeframe, the Obama administration had begun to look at new policies that would encourage economic development in the US. And industrial policy was very much focused around encouraging new ways to bring spectrum to the market. In the US, we face this unique challenge, I think, that a lot of the spectrum is utilized by other users. And one particular user is the US Department of Defense. They have actually a fairly large footprint on spectrum below 6 gigahertz that they occupy for federal uses. So the concept at that time was to look at new innovative ways using cloud technology and other capabilities to begin creating faster ways to bring spectrum to the market, more flexible ways to bring spectrum to the market, and again, leveraging these new technologies around cloud automation to make that possible. We are today a 85-person company, and our team includes scientists that work with machine learning, that are experts in algorithms, RF propagation modeling, RF and wireless networks. So a very diverse team of folks that we brought together to help make this spectrum sharing concept a reality.
Thank you, Kurt. And our main product is what we call the Spectrum Controller. This is a cloud-based software capability with a robust, redundant, nationwide sensor network that is specifically designed and geared towards listening for the Department of Defense incumbent use in the 3.5 gigahertz CRS shared spectrum framework, which we'll get into more details later. We've been running on a commercial basis for about a year and a half now, a little bit over that. And we have over 170 customers accessing the 3.5 gigahertz band, including the major mobile network operators, cable service providers here in the US, quite a few fixed wireless service providers, and a whole host of enterprise private network users. The CRS framework also includes over 40 equipment providers, whether those are base station or end user devices. It's the who's who of the radio equipment vendor community. And the capability that we have been operating on a commercial basis in the 3.5 gigahertz band is easily adaptable to other frequency bands and other opportunities for shared spectrum access. And this includes the 6 gigahertz band, where we are a prospective automated frequency coordinator, or AFC administrator, for the 6 gigahertz band, where we are going to be enabling unlicensed devices to share spectrum with a variety of incumbent users there as well. So very flexible software, cloud-based capability within the Spectrum Controller that can be tailored to meet different frequency bands and different shared access approaches. So all of this comes out of, as Kurt mentioned, an effort by the US government a decade or more ago to figure out how to make more efficient use out of the 3 gigahertz spectrum in particular, which the US government had quite a few Navy radars operating along the coasts, as well as in at certain bases on land as well. In the 3.5 gigahertz band, we also have a number of commercial fixed satellite service users and some grandfathered fixed wireless service providers that were using 50 megahertz of spectrum on a lightly licensed basis for 10 to 15 years. And the government said, all right, how can we enable better use of this spectrum, knowing that the Navy's use is extremely important, but it's itinerant and it is in specific locations for specific amounts of time. And the rest of the time, that spectrum is basically sitting fallow and underutilized. So they came up with this concept of a tiered shared access framework, where the incumbents, who I've already listed, get to be the highest tier, the highest priority tier, and it's their use that everyone else needs to accommodate and protect. Then they figured out a way of introducing 2 new tiers of commercial users. One is on a licensed basis, the priority access licensees or PALs. The other is on an opportunistic or lightly licensed or use by rule basis or general authorized access. And that is the lowest tier of user. And these 3 tiers are managed by the Spectrum Access System or SAS, which we are one of the administrators for after having been certified by the FCC, the US Department of Defense, and the National Telecommunications and Information Administration, or NTIA. And our cloud-based system enables the sharing between the incumbents, protection of the incumbents when and where they need to use the spectrum. We also manage the priority access licensees and ensure that their use, which is a use it or share it use, not truly exclusive, where their actual use gets protected by any from any lower tier GAA users. We make sure that they are able to access the spectrum where and when they need it. And then we also allow GAA opportunistic users to access any leftover spectrum that's not being used by one of the higher tier users. While all of this was again conceived in order to make more efficient use of the Navy's spectrum, it really has quite a number of additional benefits for both, MNOs, cable companies, these fixed wireless service providers, as well as this wide range of new private network enterprise users that we'll go into in more detail. Kurt?
Great, thanks, Jennifer. While we're on the slide, it might be instructive to point out that this concept, this sharing concept, and the use of cloud software to enable sharing isn't purpose-built just for protecting incumbents. In fact, the sharing paradigm could exist in a band that doesn't have incumbents, but you want to, as a regulator, set up different tiers of access and create or attribute different rules or different regimes associated with those different tiers of access. So take, for example, the priority access licenses, in general, authorized access licenses, where there would perhaps be no incumbents, could be a system that we could, or a sharing paradigm that we could easily implement using the same technology. And that really, I think, speaks to the flexibility of this approach and the uniqueness of it, because this is through this cloud software platform, we're able to really create these very unique and distinct forms of access for different user categories. And that's something that really can only be effectuated through software control of the band, not really capable to, or possible to do that through other forms of shared access like contention-based protocols built into equipment. So again, this flexibility of this sharing paradigm, I think this is one example of how this works in CBRS, but there are, of course, other ways to implement it. So I'll spend a few minutes talking about how the spectrum sharing system that we've deployed commercially actually operates. There's really 2 main components associated with the system. The spectrum access system, as Jennifer mentioned, that is the cloud software, which is really the core engine that does all of the spectrum management. that platform is constantly computing and recomputing the network. And what I mean by the network is for every Spectrum user, their network nodes, so think in the 5G context, that would be a G node B, or in 4G an E node B. Those devices, those network nodes, connect to the SAS through a lightweight protocol, an API, which is used by the device and the SAS to register the device, authenticate the device, receive information about the device's location, its intended operating parameters like its height and antenna type and other things, and then ultimately assign and manage the spectrum associated with that particular network node or device. And we do that through, as I was alluding to, this constant calculation and recalculation of the network. So think of this as a massive real-time network planning capability, where we're computing RF propagation, we're assessing the potential for interference to different tiers of users, and then we dynamically allocate spectrum. And the allocation of spectrum includes both the transmit power that the network node can operate at, the bandwidth that it is permitted to operate with, and the specific frequencies of operation. So a spectrum grant that is authorized for each one of these network nodes that connects to the SAS includes those three main components. The sensor network is a unique aspect for sharing in the CBRS paradigm. And that sensor network is a collection of of sensor nodes that are deployed and operated by us, that are used to identify when this unique incumbent user, the U.S. Navy, is operational. So of course, Navy radars turn on and off, the ships move around, and because of the nature of their use, we needed some way to accurately detect when a radar is in operation, and generally where it is in operation, to understand what protection requirements may be necessary. And that is the sole purpose of the sensor network, is to really operate and interact, if you will, with this particular incumbent, and inform the spectrum access system of any corrective action or action that's needed to provide protection to the Navy radars. Again, this is a unique aspect to provide protection to these unique incumbent. Really, the SAS being the core engine is something that could, be extensible to other spectrum bands or other applications where, sensors aren't necessary to identify incumbents, because perhaps a database could be accessed to understand where incumbents are located. Or again, if there are no incumbents in the band, the SAS would be used to do the dynamic management of the different access or user tiers.
So as I mentioned, the CRS Band 3.5 to 3.7 gigahertz has been operating commercially for about a year and a half. We were granted authorization to begin commercial use on a limited trial basis in September of 2019, and then granted full commercial deployment authorization in January of 2020. The graphics here on this slide are from the OnGo Alliance, which represents the CBRS community, both the operating community as well as all of the technology, software, and equipment vendors. And as you can see, this is a huge ecosystem of companies that are all participating in the CRS band. Ostensibly, this could be the largest ecosystem for wireless technology in any band. We've got over 190 members in the OnGo Alliance, and it continues to grow. Since commercial launch, we are up to, as of this date, almost 150,000 base stations, eNodeBs, whether those are small sites or larger wide area network deployments. It includes both of them, but this is one of the fastest growing deployments that we've ever seen. In that year and a half, 150,000 have been deployed across the country. And initially, those were all deployed in the general authorized access tier, the opportunistic tier, by hundreds of different users. And it's really impressive to see how how much of that deployment occurred before the FCC's auction for the priority access licenses, which was held last summer and early fall, had even begun. Uh, what we, speaking of that PAL auction, bottom right corner, we brought in over $4.5 billion worth of revenue from the licensing of the PALs, which were acquired by over 228 different licensees. That's a record. Never have that many different entities participated in an auction, never mind walked away with one or more licenses. So just about a month and a half ago, we started implementing the priority access license use of the band after the FCC completed its process of authorizing the specific winners and converting them into proper licensees. So in addition to the 228 PAL winners, we have hundreds more operating and continuing to operate on the GAA spectrum. So we're looking probably at multiple hundreds of different diverse users operating in this frequency band, all because of the different access options that have been made available in the shared band. So as Kurt said, the original idea was to make better use of the spectrum while protecting incumbents. But the other really important part of the CBRS framework is these multiple access options, whether you want the security and surety that comes from having acquired a PAL license, or your use or business opportunity enables you to take advantage of the very low cost to basically barrier-free entry to this incredible spectrum band, which is again being used by hundreds of different users today. And then finally, if you look at the number of devices that this ecosystem represents, we're again talking about hundreds of different devices being available, whether those are base station devices or end user devices. And you can see there from the top right graphic, the FCC authorizations and what those trends have looked like over the past year and a half to 2 years. With the extremely diverse range of vendors supplying and supporting the CBRS ecosystem. Kurt, any other thoughts on CBRS market and how it's developed since we went commercial?
Yeah, I think one other thing that's worth pointing out at this point, and you'll see it in the reference to this in the graphic in the lower left on the acceleration since launch slide. CBRS supports multiple categories of device power limits. So both a lower power and higher power category, what we call category A and category B, based on the FCC designation. But the important part about this is that because of the use of the software platform, the spectrum access system, to effectuate sharing, and because of the deterministic way in which we predict interference and actively provide incumbent protection, we don't need to rely on low power alone as sort of a fail-safe or protective measure to assure incumbent protection. And that then affords the ability to operate at much higher power levels than would otherwise be authorized or possible in unlicensed bands. So of course, unlicensed bands where Wi-Fi operates, typically the transmit power is around 1 watt of EIRP. In the case of CBRS, we're able to operate all the way up to 50 watts of EIRP. And that additional power really then creates a much broader and diverse range of use cases that can be supported. So much of what Jennifer is talking about in terms of the participation of MNOs, of cable, the diversity of equipment suppliers and end user devices is also attributed to this fact where we have this shared band where anyone can use it. And this creates lots of interesting new applications, but also these different device categories, these base station transmit power categories, which allow for different use cases, a more diverse range of use cases to satisfy the needs of mobile network operators, of other service providers, and those who are looking to deploy private enterprise-like networks. So speaking of which, we've talked a little bit about some of the use cases. Jennifer, do you want to cover this slide, and then I can talk a little bit more depth on where we're going with each of these different use cases?
Happy to do so, and we've alluded to this in some of the earlier slides. We're seeing a very wide range of different use cases from the different sectors that are all actively using the CBRS band. Traditional wireless companies, the big mobile network operators, are using CBRS for network densification, increasing their capacity, starting to implement 5G solutions, and carrier aggregation, aggregating the CBRS band with other licensed holdings that they have to achieve 5G capabilities, even today using 4G equipment, but ultimately migrating those systems up to 5G when and where they see the need for those enhanced capabilities. In addition, we're seeing new entrants for public wide area networks, including our cable companies who are using the CBRS band for last mile connectivity. They currently have offerings of mobile operations or mobile services through an MVNO relationship with one or more of the larger MNOs, and they're looking to offload that capability onto their own networks. And CBRS is the core band for that offload, particularly for wide area mobile usage. They also are going to be using this CBRS spectrum for enhanced capabilities at hotspots, as well as smart home applications where they will combine it with Wi-Fi that's terminating on their wireline networks. Then you get the neutral host approach. This is where a building owner or a venue owner deploys a network using CBRS to support the roaming of the MNOs or the cable companies' other wide area networks. This could be an airport, an apartment building, shopping malls, arenas, where you've got a lot of different people coming into the space, and it doesn't make sense to replicate distributed antenna systems for each of the major mobile network operators. So providing a neutral host capability is a far more cost-efficient way of doing this, and CBRS is the band that the MNOs have agreed to use as a common roaming band. Another important category of use cases is the fixed wireless access or wireless internet service provider, WISP market. And as I mentioned earlier, there were quite a few WISPs who were using part of the CBRS band for the past 15 years on a lightly licensed basis. But their ecosystem was sort of limited to older technology that wasn't migrating, wasn't evolving, and they were stuck with a limited number of vendors supporting that older technology. But now that they are able to take advantage of the 3GPP ecosystem and vendor community, given their ability to share this spectrum with the larger mobile network operators. And I think this is a real advantage for fixed wireless access, is having the ability to take advantage of the latest technology, an increased number of vendors, and the prices for that equipment and therefore their service capabilities are really expanding. We're seeing a lot of this activity in rural areas where they're increasing their capacity and speed, as well as the price points at which they can deliver better service. And then finally, the last area we're seeing a lot of growth in is private networks, and that's what we're here to talk to you about today. Is all of the enterprise use cases and applications that are supported using the CBRS band and the 3GP community of technologies that are being able to take advantage of having the combination of licensed as well as unlicensed access options in the same band. Kurt, I'll turn that over to you again.
Great. So when we look at private wireless networks, the opportunity that lies ahead is enormous. This is clearly the promise of things like the Internet of Things, the predominant use case that is driving adoption of 5G beyond, increasing bandwidth and reducing latency for consumer capability. This is where the new growth related to 5G deployments is anticipated. And as we think about the needs in a post-COVID world for increased amount of worker safety, automation, the Industry 4.0 phenomenon is very much aligned around the need for connectivity solutions in a very broad and diversified range of applications, everything from healthcare to commercial and retail uses to large venue and transportation hub needs. What all of these sort of diverse use cases have in common, however, are a couple key components. One is the ability to offer both a private network capability as well as potentially some open access support for things like, the ability to bring carrier networks indoors, like in stadiums or large transportation areas, such as through neutral host. A need for very high performing networks that are ultimately low cost, and the need for security of data, security of the end user connections, the assurance that these networks will be safe and secure from cyber attacks and other activity that might compromise the applications. So, for example, as we look at some of the Industry 4.0 connectivity needs, and in this case, kind of looking at particular needs around warehouses, smart manufacturing facilities, logistics facilities, what you quickly find is that the range of applications include both retrofitting communication capabilities to existing infrastructure, like connecting equipment that is used for assembly of equipment or product, to moving robotics and the moving of inventory around the factory or manufacturing facility. Some cases this is existing infrastructure, in some cases new infrastructure, but providing real value to optimize the capabilities, assure that the equipment uptime is maintained, installing sensors and all sorts of other capabilities to automate these particular applications. Two, in addition, from retrofitting the existing infrastructure to adding all of this new capability to make the building itself increasingly smart, like building operations for HVAC lighting, providing enhanced security and health and safety applications. So this could include much more much broader ranges of video surveillance, temperature scanning, other infrared capabilities, things to again manage worker safety, all the way to employee communications, providing the ability for very integrated communications for employees, for the workforce, maybe on the factory floor, as well as management, security personnel, operations personnel, to all be able to share a common communication platform for voice and data. So very, again, a very broad and diverse range of needs, but also this key, need is the ability to be able to bring this connectivity solution to existing infrastructure and while adding new capabilities. So as I described, this architecture starts to play out in the form of different devices, gateways that maybe are connected to the existing infrastructure, and then embedded capabilities that go into, for example, scanners or ruggedized devices, closed circuit TV cameras, other surveillance, video surveillance capabilities, which will have, an embedded functionality, all working through an edge compute platform. And we really believe edge compute is a key component associated with Industry 4.0 and private wireless networks. It will be a key enabler because it provides the application support and data security necessary for the enterprise to have a truly private wireless network. So you can think of this sort of network bubble that is, the key component of the private network, and then through a SD-WAN capability or secure firewall, it can also, this private network can also access other applications that might sit in the public cloud infrastructure, different IoT platforms for, supporting other applications within the automation environment, just more cloud compute resources that might be necessary for, applying any of the machine learning or other algorithms that are used for example, for the automation of forklifts or automatically guided vehicles, to other third-party applications that might be part of a suite of workforce applications that run on employee devices. But again, the key, pillar I think that supports this whole network concept is the ability to deliver something that is highly secure, delivers the bandwidth and latency performance, and is truly under the control of the enterprise in terms of being able to meet their specific needs. So that's really, to sort of summarize, that's what we really describe a private wireless network to be. Clearly there are sort of all sorts of different terminology that's used in the industry to describe private wireless. We really describe it as a network that is fully owned and operated by the enterprise itself. What it is not is a network slice provided by the MNOs. What we have largely seen here in the US is that many enterprises want full and complete control, and they want the ability to own and operate a network independent of the mobile network operator. And in order to do that, spectrum becomes the key enabler. And that's really where CBRS fits in. And that's what's so exciting about CBRS as an application or capability for enabling private wireless, is that it's this massive swath of spectrum, very deterministic, high quality service access that really underpins the ability for the enterprise to own and operate its own 5G network. I mentioned things like enterprise grade security, for example, zero trust architectures, which are, now becoming the norm for cyber and other security needs within the enterprise. Having a network architecture that supports that capability with 5G adds the scalability and edge compute capabilities that are necessary for applications, for low latency, for keeping data on premise. This is really how we see the private wireless market evolving, and where we, predominantly hear from customers and partners that we're working with as the real opportunity for private networks with 5G. So again, to sort of bring this all together, as we talk to enterprises and partners about when would they want to consider a private wireless network and why would they consider a private wireless network, it really comes down to these 3 C's: coverage, control, and cost. And this is how 5G in a private wireless context on shared spectrum, for example, using CBRS, really distinguishes itself from other private wireless capabilities like Wi-Fi, or a network slice, a 5G network slice offered through the MNO or other service provider. Really, a privately owned network that's owned and operated by the enterprise using 5G on shared spectrum is the ideal way to meet the coverage requirements of maybe covering large indoor environments, combined indoor and outdoor environments, which is quite often the case in many industrial applications. Being able to achieve the stability of the network, the high bandwidth and mobility functionality, that's all possible through 5G, all possible on shared spectrum. The control piece is really moving it outside of a network slice with the MNO to everything being on-prem, where the enterprise IT CIO has the security functionality, the quality of service, the leveraging the other capabilities like SIM authentication and edge compute to keep traffic on site. These functions really give them complete control over their wireless destiny and their connectivity needs. And cost, by this network being completely owned and operated by the enterprise, tapping into this massive ecosystem of equipment and devices that CBRS enables, they're able to get a diversity of equipment suppliers, very low cost infrastructure, potentially less infrastructure than is needed for things like Wi-Fi because of the higher power for outdoor uses, as I described previously. All of these things come together as providing great cost benefits to the enterprise. So what I'd like to do is maybe walk through a couple examples quickly of how this has actually become a reality here in the US using CBRS. And the first example is a 5G smart warehouse project that we were awarded by the DoD. Now, this is not a research project. This is really the US Department of Defense, as the largest enterprise user in the US, tapping into the power of shared spectrum, a band that they already use for their military applications, now using for sort of their own logistics needs, their own internal communication needs, to provide logistics functionality at a Marine Corps base. Now, this is not your average warehouse. This warehouse has tanks and weaponry and computers, as you can see, and all sorts of logistics needs, and they have massive amounts of equipment moving in and out when they're conducting missions. So this is really in terms of the scale of complexity of inventory management and control and other things, a really massive effort where they need much greater degrees of automation than clipboards with paper offer them today. So really exciting project. This is now being implemented. We actually just recently completed a very exciting real-time demonstration of this 5G capability at our offices here in Arlington, Virginia for the DoD, demonstrating all the different applications that are everything from very straightforward equipment and logistics functionality to this interactive hologram or holographic capability where, quite literally with a device in the palm of your hand, you can see in 3D the operations ongoing within the warehouse using this, through all of the sensors and other wireless capability that we're offering. Another application for private networks, and this is one that's been particularly important during the pandemic, is remote distance learning. So in this case, McAllen, Texas, which is located in South Texas near the US-Mexico border, is a thriving community. It's a growing community, but many low-income areas that really face challenges to go online to do remote or distance learning because they really do not or cannot afford to procure or purchase broadband through a local service provider. So the city, taking actions into their hands, decided to deploy a private network that would be used to provide connectivity and backhaul to Wi-Fi access points so that they could reach the students through, for example, Wi-Fi connected laptops or through direct CBRS connections on the 3.5 gigahertz band to provide a distance learning functionality. And this was a network that was quite literally stood up in a course of a summer. So school year ended in June of 2020, and then by the fall of 2020, this network was up and running over much of the McAllen, Texas area to provide connectivity for students as the school year began. And this was all accomplished through federal funding that here in the US, we've had several federal funding programs put into place to help stimulate these private network deployments to bring about connectivity solutions for the unconnected for things like distance learning. Another application, and again, this one was related to COVID, was for a large quick serve retail provider who needed to move their operations outdoors, needed to provide a drive-through like capability for their patrons where one did not exist. And moving a digital kiosk from inside the store to outside the store actually presented quite a bit of logistical challenge without the ability to bring Ethernet outdoors, or the cost and expense of trying to trench and bring fiber outside, the time required to do that. It was completely impractical to try to do this through conventional fixed connectivity solutions. And Wi-Fi just simply wasn't reliable enough to even reach out into the parking lot to provide a connection to the kiosk. So they explored the use of CBRS and shared spectrum, the higher power again, and other things to be able to move these kiosks outdoors to provide more secure and reliable connectivity for their sort of ad hoc outdoor service in response to the needs of COVID. And another really exciting application, and this is one that we see growing quite a bit. It's very early days, but we think this is an outstanding application for private networks and CBRS or shared spectrum is healthcare. The wireless environment in any healthcare facility is a very challenging one indeed. Lots of Wi-Fi capabilities, both from a public patient guest network need, as well as devices that are operated as part of the hospital operations. Maybe the operational staff and other folks are using the Wi-Fi network, and the actual medical devices connecting via Wi-Fi or other unlicensed band, proprietary unlicensed band functions. This presents a very demanding environment where connectivity becomes a real challenge, particularly for that last category of use, devices that are used for administering healthcare. So CBRS will create this unique opportunity to move all of the hospital devices, all of the private, devices, if you will, onto a private network that is secure, reliable, leaving the Wi-Fi network in place for guests, hospital patrons, patients, other, sort of public access needs. So clearly, Wi-Fi is a technology that has brought about tremendous advances, and it's certainly not a technology that is going to be replaced. And that's why these private wireless network functions, I think, provide a very unique and distinct capability, in some cases very complementary to Wi-Fi. And we see the growth of this to be both in Wi-Fi as well as in these private network functions over 5G.
Thank you, Kurt. And that's just a sampling of the various enterprise capabilities that are being enabled through the shared spectrum framework that is the backbone of CBRS. And in terms of the lessons we've learned from operating CBRS for the past year and a half on a commercial basis, that I think are relevant for the European spectrum management audience. The first and most important is that automated shared spectrum technology works. We've proved that it works. It took a long time to develop and to get agreement on how it would be implemented. And there were lots of checks and balances that were put in place before we were authorized to go commercial. And I know it took longer than many people had hoped, but we are very excited at what has actually emerged in reality. And just as an example, you probably heard this before, but we have not had a single incumbent complain about receiving interference from any of the new commercial users. And as we discussed earlier, the commercial users' experience has been wildly successful as well, with the fastest deployment, wide scale, 150,000 cell sites deployed to date. It's just amazing how the CRS band has exploded, since being given authorization to move forward commercially. But the bottom line here is that the automation capability, the software, the automation is the way to expand and modernize spectrum management. We heard at the DSA summit last week, Augustino from Anatel say that exclusive licensing is so old school. Well, I also think that manual coordination and or overly regulator-focused management of spectrum bands are also going to be old school, and that what we're going to see is software and automation and AI capabilities being applied to this important area of maximizing spectrum use and supporting innovation by the greatest number of users possible. And to that end, as Kurt mentioned, this is not just about sharing with incumbents. This can also be the same technology can be used in bands that are clear, they're greenfield, and just providing different ways for different users to access spectrum. You can still auction part of the band off for your MNOs to continue to increase their capacity for large large-scale public wide area networks, while at the same time enabling private wireless networks and verticals to access spectrum where and when they need it, without having to go through the painful manual coordination process or even a first come first serve licensed approach, which can be time consuming and is a little less clear in terms of your investment opportunities and timelines. Knowing ahead that you're going to be able to get access to spectrum within a matter of hours, I think is really important for investment and innovation. And that's what the automation and software capabilities really bring to the spectrum management process. And it also drives a robust ecosystem. I mean, we've got the largest ecosystem we've ever seen, partly because we are leveraging the economies of scale of a band like 3.4 to 3.8, where there was already a great global trend towards using that spectrum that we're able to leverage to make CBRS successful. But having the community that's going to be serving the licensed community, the MNOs, cable, other large users who want the surety and security of licensed spectrum, that combined with the much larger group of enterprise users and vendors supporting that community, I think is what makes this so successful, and it's really the secret sauce of CBRS. And as we look forward to, where in Europe this technology, this capability could be deployed, I think we're looking at the 3.8 to 4.2 band as an obvious choice, given our experience already in sharing spectrum with FSS systems in the US. We think there's a lot of promise for sharing that particular band as well. But again, it can be in any band that is available for terrestrial flexible use broadband services, whether you've got to deal with incumbents or you're planning to migrate those incumbents out over time. The automated spectrum sharing technology will enable you to maximize that spectrum today and as the band's use changes over time. Or if you've got greenfield spectrum, enabling different tiers of access, we think is really the right way to go to make sure that your MNO community has what they need while also enabling private networks. Now with that, we would like to, we'll go in a couple of minutes of Q&A here. We're sort of running short on time, but Kurt, maybe you could go to the last slide and we can tell folks how they can reach us with any questions or follow-up. We're not available for live Q&A here with you today, but we are available for future discussions. So please feel free to email either Kurt or me, and we would be happy to answer questions and to continue this dialogue. In closing, Kurt, what do you think the lessons are that we've learned that you think would be relevant as European regulators are looking at new spectrum options and at enabling private wireless? I know Germany's been obviously been implementing it set aside in the 3.7 to 3.8 band. Ofcom has enabled sharing on a hyper-local basis, on a first-come, first-served license basis, and those are great steps, we think, towards making additional spectrum options available. But if you were to give one lesson about what we've done in CBRS and why we think it is the next wave of that sharing, what would it be?
I would point to the ecosystem, Jennifer, as being one of the most key aspects. Setting aside spectrum for enterprise uses or industry 4.0 uses is, if there's spectrum available, is perhaps a relatively straightforward process, but it doesn't assure success. Without a large and vibrant ecosystem, equipment suppliers, device manufacturers, and users demanding access to the spectrum, to create that ecosystem, to bring innovation, to bring low cost, it will be very difficult for those bands to hit this sort of adoption and meet the uses that the enterprises have. If ultimately a spectrum set aside is not a more cost-effective option than the MNOs providing the service directly, there was no point in doing an MNO, a set aside for spectrum for the for that industrial application. So you really need to radically change the economics associated with this while putting control in the hands of the enterprise for their network deployment. And I think what we found with CBRS is when you're able to create that massive equipment ecosystem, a massive device ecosystem, that really translates to a variety of use cases and cost, which is really compelling for enterprise uses.
And just to add to that, I would say, from my perspective, that the automation of the process that the regulator goes through when it's issuing hyper-local licenses, that automation capability, I think, can really speed up access and speed to market. And maximization of spectrum efficiency. We don't necessarily need to limit someone to on a first come first service basis. We may be able to authorize multiple users within the same geography, depending on their use cases and how they're deploying their networks. And furthermore, not having to wait for the regulator to get back to you to say, okay, we've negotiated with the incumbent or we've negotiated with your neighbor, and it took us 4 months, it took us 5 months, it took us 6 months, and you might not be happy with the results. Having some bright line tests and that automated capability where we can get you an answer within a matter of minutes about what spectrum is available to you for your use case and application in that particular geography, I think is another major benefit of the spectrum access capability that we've automated. Well, with that, we'd like to thank you very much for participating in the Federated Wireless Showcase here at the European Spectrum Management Conference, and look forward to speaking with you further. Feel free to reach out to us, and thank you for your time.